In this example, we have compound Z. It was isolated from balsamic vinegar, analysed by Proton NMR and IR spectroscopy. The infrared spectroscopy has told us we've got a peak in that region. If we look that up on the data sheet, we know that this is an OH bond in an alcohol. So we know we've got an alcohol group in our structure. Then we've got a table of NMR data. And I'm just going to delete that because that's the wrong data table. And let's just bring down our data table here, put it on this question. So that's more useful to us for this question. Just rub out the writing. So we've got this nice NMR, Proton NMR data table. What have we got in this spectrum? So we've got to use everything we've got to figure out our structure. So we've got 1, 2, 3, 4 peak informations. So we must have 4 peaks. Let's take each one at a time. Usual to start actually what we call upfield with the bigger numbers, delta 4.38. So let's go to the data sheet, see what 4.38 could be. Now, what we know is if we look down the list, 4.38 is not in that. It's not really in any of these, but it is in here. And we do know that that makes sense because it's a singlet. And we know that alcohol peaks are not split and do not cause splitting. So we know that that could be true. And it's of integration 1. So it's got no next door neighbours. It's got one hydrogen of that type. So altogether, this is probably RROH hydrogen. So this is our OH proton. Then if we go to delta 3.5 and we have a look at our data sheet, so let's do it in a different colour actually. Let's go for orange. 3.5. So we go to our data sheet. Now, we've got a choice. It could be this, or it could be this. And given that we know we've got oxygens in our structure, it's much more likely to be this type. So let's write down what else we know about it. We also know it's a triplet. And we also know that the integration is 2. So what does all this information tell us? Well, the 3.5, we're thinking, given that we know we've got an O in our structure, is likely to be this. The triplet, remember that's about how many are next door using the n+1 rule, so next to 2 H's. And the integration will be 2 H's of this type. Okay, so probably a CH2. What could this be? This is then likely, from all that information, to be, they are the O, they're part of another part of the molecule. So 2 H's of this type. There we go. Next to 2 H's. So it's likely to be this, which then must carry on to somewhere else. So we've got the first piece of our jigsaw. And then if we move on to the next piece, let's see what we've got next. We've got this 1.4 triplet area 2. So this was this one. We've now got our delta 1.4 triplet integration 2. So 1.4, we go up to our data sheet and we go 1.4 doesn't really tell us much apart from that it's probably a chain type. Triplet next to 2 H's. Integration 2 H's of this type. So put all that bit of information together and we're probably looking at a piece of a jigsaw puzzle that is not a CH3 but a CH2, 2 H's of this type, next to a CH2 It's kind of repeating the information that we had before, but this is not the part of it that's next to the alcohol. So it's probably the other end. Same section, other end. Then if we go and look at our final peak, take a different colour, and we go 0.94 singlet 9, that's interesting. That's a bit different. 0.94 singlet integration 9. Now that integration 9 is a bit of a red flag. It's telling me something different, something that I probably will pull together and know. I know this isn't telling me very much interesting information. It's just like the H's on C's. Singlet next to no H's. So no H's on the neighbouring carbon. But integration 9, 9 H's of the same type. Now that is always like a little clue to this 3 CH3s all joined to the same C, and then you can see why there's 0 next doors, because the C in the middle here can't have any hydrogens on it because it's joined to the rest of the chain. So we've now got our sections of our jigsaw. We just need to pull it all together. So we've got the 9 equivalent CH protons here. So this was our green bit, CH3, CH3, CH3. They are then attached to the CH2 that is at 1.4, which is attached to the CH2 that is at 3.5, which is attached to the OH, which was this peak, which we didn't colour in, but if we give that a colour, say blue, that one there was this one, and that has ended up being this particular peak here. You can see that that structure satisfies all of our information.